Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom.
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're going to be doing Co-working Tuesday today. All right, everybody, it is Tuesday, August 11th. August 11th, right? 2026, and it is time to do some co-working for the next 3 hours or so. We're going to be doing some co-working, so if you have something to work on, so if you've got homework, or if you've got a course that you're doing right now, then please feel free to do that in the background while I work on my C programming course over here from EduB Interactive. And if you want to learn C as well, you can take part in this course over here for free. Here's the link. And without further ado, let's get started. We'll put a couple of hours on the clock, and we'll see where we're at after a couple hours. We'll probably add another hour after that, and then we will finish up the stream. Pardon me while I click up on the timer. Apparently this program that I'm using right now doesn't let us manually put in the time. We have to click on it a bunch of times. All right, so that is 2 hours on the clock. Should be appearing on the screen. Okay, good. And let's put a little bit of music on in the background while we work. Okay. Okay, what is this? The 80s? Bad programming. Bad programming? I don't know. I don't know about bad programming, but, well, we're trying to learn programming anyways. If you have to click, oh, okay, that. Well, I mean, yeah, I guess it's kind of like using 80s programming. I like 80s programming languages. What programming languages were created in the 80s? I'm pretty sure that the programming language that we're doing right now, C, was created in the 70s. But I think C++ might be from the 80s. Let me know if that's the case. Okay, so we're currently talking about character arrays over here. So arrays of characters, the strings. Character arrays are treated in a special way. We've just declared an array like this. Character, protagonist 10. So this array is capable of storing 10 characters. Do you know that when we use similar tables? Do you know what we can use similar tables of this kind for? Nullsec says, I don't even know if I've had mice yet. If they had mice yet in the 80s, it was just hyperbole. I'm pretty sure, I mean, I didn't have a mouse. I didn't have a mouse up until like the 90s, maybe like the mid-90s. Not for my computer, it was just a keyboard. But hey, Cypher, hello, nice to see you here, and welcome to the stream. Do you know what we can use similar tables of this kind for? Well, they're indispensable whenever we need to process text. The most obvious example is personal data processing, first names, last names, places of residence, etc. These values are called strings. So our array is an example of a string. Imagine that we're going to use it to store the name of our favorite protagonist. At the moment we're wondering if it's Bilbo or Potter. Is it Bilbo or Potter, everybody? Now we have a question to answer. The table has room for 10 characters. Bilbo is 5 characters long, and Potter is 6. How do we know in advance how many characters we want to put into an array? And when we put it in there, how do we know how many characters are really used? How do we discover where the end of the text which has been assigned to the array is? We cannot use the size of operator for this purpose. Cypher says Bilbo. Nullsec says I'm more partial to Potter, but Lord of the Rings is still pretty good. I mean, it really depends on what era you grew up in, I suppose. So if you grew up in the 90s, then you might be more into Harry Potter than Bilbo Baggins. It'll tell us how many characters are occupied by the entire array, but it won't tell us how many of them we actually use to store the name. This issue is solved in the C language in a special way. Every string must end with a special tag, something like a flag waving in the wind and announcing, here's the end of the string. All subsequent characters have no meaning. This role is played by the character with the ASCII code equal to 0. This code does not represent any visible characters and doesn't have any special meaning for input-output devices. According to C language conventions, the terminating tag is denoted in the following way. Note it's a 0, not the letter O. So it's a /0. Lord of the Rings has cooler names. True. Lord of the Rings has a lot of like Finnish / Nordic inspired names. But hello, Hat Knight, nice to see you here. Okay, we call this character an empty character or null. Don't be confused, it has nothing to do with the null pointer. The convention, though easy to use and understand, has one significant flaw. Since we must use one character to indicate where the string ends, it means we can only use 9 characters for storing the text. This is the price we pay for convenience. Okay. So how does it work? How do we store the name of our Hobbit hero in the array? There are several methods. The first is very inconvenient, and we only want to show you in order to discourage you from doing it yourself. We can store the entire name by storing each character using a separate assignment, as shown below. So protagonist element 0 is B, and then I, and then L, and then B, and then O, and then null. This seems very tedious indeed. Okay, note the character we stored in the 6th element of the array. We can initialize a character array in the same way as any other array, like this. So character protagonist with a size of 10, Bilbo, and then the null character. Unfortunately, we can't do this in regular assignments. Okay? Let me turn down the volume just a bit. Okay. There's another method for initializing character arrays. Don't forget, it only works with character arrays. You must not use it for any other kinds of arrays. So this is what it looks like. So character protagonist 10 equals Bilbo. Okay? So you put it between some double quotes. You probably want to ask the following question. Where is the ending tag? Did you forget about it? No, we didn't. Strings could be pointers. Whenever a string appears in the program, like the one here, from A to J, the compiler treats it in a very special way and performs the following steps. The compiler counts how many characters are inside the string, for in our example it's 10. The compiler reserves memory for the string, but gets 1 character more than the string's length. In our example here, there will be 11 bytes in use for the string. The compiler copies the entire string from our source code and into the reserved memory, and appends an empty character at the end. Pay attention, this is the most important step. The compiler treats the string as a pointer to the reserved memory. Don't forget, a string is stored as a sequence of characters followed by the empty character, but behaves as a pointer of type character. So character pointer. Okay, we can go back to arrays now. Alright, so we've got another exercise. So string initializations have an interesting extension. Take a look at the code in the editor. It seems that we forgot to provide information about the array's size, leaving only 2 empty brackets. But don't worry, everything's okay. That means we want the compiler itself to count the characters. The compiler will add an empty character to the string, so the declaration works the same way as this one. So character protagonist 6, so 6 size array, equals Snape. So this is 5 characters plus a null. The array size is larger than the initiator length by 1. Hacker Macho, hello, nice to see you here. Hey, got you from the Level Effect livestream. Level Effect livestream. NetDBG, hello, nice to see you here. I don't know Level Effect. Let me look him up on YouTube. I'm just doing this off stream, and what's going on over here? So what do they stream live? Cybersecurity certs without multiple choice, live cybersecurity resume reviews, Continuum Con 2026 Day 2. Oh, okay. It seems like a pretty big channel. Yeah. Awesome, awesome. Nice channel to know about. Thanks, Hacker Macho. Okay, so tonight we're going to be doing a pretty chill stream. We're just going to be working through the C coding course, and I encourage everybody, if you're not paying attention to the C coding course, you can work on whatever you want. It's something called co-working. It's basically sharing a space, in this case like a digital space, with people who are learning, so you feel more motivated to learn. Okay, so character protagonist Snape, and if we, what happens if we try to print something? So printf, in this case it would be like a string, protagonist, okay, and then I think we also need to do the include here as well. So include standard.io, standard.io.h, right? Okay, and we'll try running this program. Declaration specifiers or something protagonist. I guess the other thing about this code is that there's no main function, so we probably want to define one. So like int main void, and then put some curly braces over here, and then at the very end return 0. Or at least I think that's how we do it. I need to get better at writing this boilerplate for C code. It still gives us errors. Expected declaration specifiers or something. Print protagonist. Print string protagonist. What else? Hacker Mantra says he does live streams of Security Operations Center from basic to L2 analyst. Thank you for your appreciation. Yeah, I need to add more cybersecurity related channels to my subscription list. Okay, so what is wrong with my C code here? So print S string protagonist, print F. So the compiler should have auto-filled the length of the array here. You know what? Let's ask the AI what's wrong with the C code so that we can learn in the future. Okay, what's wrong with my C program? Bump. The code is fine, it will print Snape. If you see a crash or an odd output, it's likely due to a mismatch between the actual program as written and what's being executed. That is, different compiler flags are an edited version. So, I guess there's something wrong on their end, not on my end. You know what? I think let's try another compilation site. So C compiler online, and see if this prints out. So we got the GDB online debugger. Let's try it out. Okay, so we'll just run this and see if it works. Okay, it does print. Yeah, so there's nothing wrong with our program. For some reason, it didn't work in the online compiler here. core ones. Core ones. Sath, hello, nice to see you here. What is up? Hope you're having a good evening. Or morning or afternoon, wherever you are. Thank you very much for following on Twitch, Rockstone Ebb. Thank you. Okay, let's go back to our course. And we'll just move on to the next part of the lesson. Assigning values. So we can use the same clear methods to assign a string into... Can we use the same clear methods to assign a string to the character arrays? Unfortunately not. If you write something like this, the compiler will not be pleased. Why? Character protagonist, 20. Protagonist equals Gandalf. So is it not going to be... Are we not allowed to assign later? The compiler sees the following. There's a character array on the left side of the equals operator. On the opposite side, there's a string. We know it's the value of the type character pointer. So it would seem that everything's okay since, as we said earlier, the name of the array is interpreted as a pointer to the first element. Therefore, both arguments of the equals operator are pointers of the same type. So what's the problem? Okay. Oh. You asked a question? Hold on. Let me see if I can locate it. Huh. I don't see the question. Let me look at the YouTube live dashboard, and then I'll see if I can locate your question. So he said something about core ones. So that's Sathe. Okay, I only see two messages. Could you repeat your question, Sathe? Okay, in fact, protagonist is a type. Protagonist is a pointer type of character, but that pointer has been designated to point only to one location in the memory, the one that stores the protagonist array, and nothing else. That pointer cannot be changed. The assignment tries to force the compiler to change the meaning of the pointer. The compiler is not going to back down on this. Making these type of assignments is simply not allowed. So we can't define a character array and then assign it later. Segfaults, hey, what is up? Hello, nice to see you here. Okay, making these types of assignments is simply not allowed. I mean, if we go to our program here, and we assign character protagonist, and then protagonist equals Snape, and we try to run this, it's probably not going to run according to what they say. So, run the program. It's probably going to give us some sort of compilation error. Ah, okay. Yeah. Okay, did you finish all the dojos from Pone College? No, I think I finished one of them. I finished the first dojo from, like, the beginner's path, but no, I haven't finished all the dojos from Pone College. I made it through, like, halfway through the reverse engineering course. But Segfault says, came back from DEF CON this week, fun times. You forgot? Oh, that's true. Yeah, so we also forgot a semicolon there. Thank you very much, Anarchist. But let's try running the code again. So it's not gonna run in the first place because it doesn't like this kind of assignment. But Segfaults, you said you came back from DEF CON. I haven't heard very much news from DEF CON. How was FedCon? Well, I mean, some people call it FedCon, yeah. But yeah, Segfaults, can you tell us anything? Did anything fun happen over at DEF CON? Tell us all about it. The comment is not landing on YouTube. I think it's because you included, like, pone.college, and it doesn't like links. Mr. Repro, hello, nice to see you here. Am I right to say that C is better than C++ for hack scripting? I mean, not necessarily for hack scripting, but I think let's write down why we're learning about C for hacking over here. Why learn C for cybersecurity? So first of all, there are two major disciplines in cyber that make use of C coding. So the first one is binary exploitation, and the second one is reverse engineering. So for binary exploitation, most easy level challenges deal with insecurely coded C binaries. So this is the primary reason why we learn C to deal with binary exploitation, is because we want to be able to solve those easy level insecurely coded C binaries in the binary exploitation challenges. So for reverse engineering, it's even more important because reversing tools, so your Ghidra, your Binary Ninja, your, what is the other one, IDA Pro, they all decompile binaries to pseudo C code. So if you're not literate in C language, you will have a very bad time. So these are the two major reasons why we learn C for cybersecurity. Okay, Segfault says, convention was fun. The craziest thing was that somebody on a flight out of Vegas used a Wi-Fi pineapple to de-auth the plane's Wi-Fi and set up a fake network and phishing page. Huh. I wonder if that guy had to answer to some angry authorities or not. Satha says, Pwn College is goated for getting started with binary exploitation and all. They have kernel security modules and all. Segfault says, pretty sure they got arrested and will never fly again. Xmetric, hello, nice to see you here. I've done that in my dreams, of course, and iPhone crashing. Yeah. But everybody, this is why we have to be really careful with our hacking misadventures. Hacking in deliberately vulnerable learning environments is one thing, but hacking somebody else's infrastructure, it can get pretty messy pretty quick. Alright, let's continue. Okay, Segfault says there were authorities at the gate when the plane landed. Nullsec said I would never on a plane. That's a... Yeah, it doesn't seem like a very good idea. It doesn't seem like a very good idea. I would imagine there's zero tolerance. I mean, anytime you start messing with anything that deals with planes, especially, you know, like during operations, it could, well, people take that stuff pretty seriously. Yeah. Okay, so let's move on. Okay, Mr. Repro says, can't we do that with C++ too? Or is it necessary to use C binaries specifically because the software is old or something? Well, I mean, I'm not too sure what the exact reason is. I mean, if you want to do reverse engineering and you know C++, but you don't want to educate yourself in C, it's probably going to be okay, because a lot of C++ code, you can probably read a lot of C++ code. You can probably read a lot of C code if you're coming from a C++ background. There's just going to be a few things you have to learn. But, I mean, if you already know C++, you don't necessarily need to teach yourself C. But, I mean, you could probably teach yourself C pretty easily, because there's a lot of the same stuff in C++. Okay, does this mean we have to separately assign each of the characters? What do we do if our favorite protagonist, for example, is King Nebuchadnezzar. Fortunately, there's a faster and more convenient solution. There's a function that makes this task so much easier. We'll show you how it works and how we can use similar functions. Don't worry, a detailed explanation is coming soon. This function is called string copy. So string copy, if people are coming from a binary exploitation background, is an insecure function. Actually, we've dealt with a lot of insecure functions so far. Hey Wrench, hello, nice to see you here. How are you doing? And did you go to DEF CON? Let us know. So string copy, it's a conflation of two strings, two words, string and copy. We can invoke it in the following way. Look at the editor. By analogy of the equals operator, the left argument is the one to which the string is to be copied, and the right is the one which is being copied. So character protagonist 6 equals Snape. The C language provides a rich set of functions that operate on strings, and we'll introduce some of them soon. Okay, so we create the character array protagonist, size 20, and then we string copy into protagonist the name Gandalf. Okay, I'm too broke to go to DEF CON. Hotel prices skyrocket. I mean, it's okay. There's a lot of local conventions as well. I'd say that most major cities, like, you know, big cyber conventions or conferences that aren't DEF CON. So the major ones are probably your B-Sides conferences. So B-Sides conferences are usually in every major city in the world. So you've got you'll have like B-Sides. Well, I mean, my local B-Sides is B-Sides Vancouver, but there's like B-Sides New York. B-Sides, I think B-Sides Las Vegas is the original one. Okay, Satha says, learning C is necessary because most of the exploits are written in C. Why do they write exploits rootkits in C? Because your OS itself is written in C. I mean, that's another very good reason to learn C for cybersecurity. So, binary exploitation, the major operating systems, so your Linux and your Windows, are written in C, so exploits for those systems would also be written in C. But I suppose for Windows specifically, you'd be writing your exploits in something like C#. But yeah, nullsec, do you know Wrench from some other community? Let us know. Or maybe don't let us know if it's a private thing. Okay, so let's see. Let's continue. So character protagonist, string copy protagonist Gandalf. I mean, let's go over to our other window over here, and we'll try doing like string copy. str copy to protagonist the string Snape. That's how they do it over here, right? Okay, and then we print out protagonist, and this should be good. Oh, from Censored Hacker's stream. Censored Hacker. Does Censored Hacker stream in English? I don't know very much about... Okay, missing array size and protagonist. So do we need to assign... I guess we need to assign like a size to protagonist over here. So that's 2, 4, 5, 6. Okay, and then we'll give it a shot again. String copy, include or provide a declaration of string copy. So is string copy part of another header? String copy C header. Yes, I've learned some AWS stuff from him. Okay, string.h header file must be included to use the string copy function in C. Okay, so that was what was wrong. Let's go ahead and include it. Okay, and then we'll try running this thing again. Now it works. Okay, great. We're learning, everybody. Okay. So a very important distinction. Now we want to show you a very important distinction. Pay attention to the examples. First, let's discuss the declaration provided in the editor. You already know that it results in the following. An array of 10 characters will be created. The following characters, Frodo and null, will be stored in the variable. Whenever you use the name protagonist, it'll be interpreted as a pointer to the first element. For example, that is the one that contains the letter F. Okay, I guess we can just move on. And now for something completely different. Take a look at the code in the editor. So it looks quite similar, but the effects will be significantly different. So we got character, pointer, hero. So a pointer of type character called hero is the string Dumbledore. Okay, the compiler reserves the memory of 11 bytes, 10 for the hero's name itself, plus 1 for an empty character, and fills it with the characters Dumbledore and null. The compiler creates a variable named hero of type character pointer. The compiler assigns the pointer to a newly reserved string to the hero variable. All right. So are we still able to print this thing? Okay, we'll try inserting this into our example here. And we're going to try printing out this hero character. Okay, yeah, it seems to print out successfully Dumbledore. Great. Okay, let's try this. Hero equals Sirius. We don't expect there to be any problems. The compiler will perform the following steps. So, I mean, we didn't declare the type of hero, so this wouldn't work by itself, but I guess we're continuing them from the previous one. Reserve 7 bytes for the new string and fill it with Sirius, ending with the empty character. Store the pointer of the newly created string in the hero variable. The regular pointer variable, in contrast to the array name, is a valid L value. Is that an L or an I? Is that the letter I? Okay, let's just continue. Can we use the string copy function like this? Yes, we can. String copy hero Pippin. The string copy function has no intention of changing the pointer's value. It only copies the string Pippin along with its empty character into the location pointed to by the hero variable. Note we have to make sure that the string being copied, including the empty character, is not longer than the target array. The compiler won't check it, it's up to you. So this is what we're talking about when we say that string copy is not a secure function. Because string copy doesn't check that it doesn't check the size of the buffer that we're copying into. So string copy can actually be used for buffer overflow attacks. Do you know for sure where the left argument points to? So the left argument, hero, points to... The left argument hero points to a character array. Is there sufficient room to accommodate the string? Well, I mean, it really depends on the declaration beforehand. Let's continue. Level of difficulty hard. Uh-oh. Familiarize a student with string, searching, characters in string, validating input, advanced loop control, printing on screen. Write a program that asks for the IP address in a human-readable form, creates 3 substrings, and prints them. These substrings are created from parts 3, 2, and 1 of the last part of the IP address. These substrings should be created with the use of pointers or array indexing, whichever you prefer. If a given string doesn't have 3 dots, then a program should print the message error, not a valid address. Your program should also check if a given string consists only of digits and dots, and that there are no more than 3 digits in each block. You don't have to check if the numbers are smaller than 256. Note you can use the isDigit function, but you can also write your own code to check whether or not a character is a digit. Your version of the program must print the same result as the expected output, so if you put in 255 4 times, last 3 parts, last 2 parts, last part. Okay, sample input. Last 3 parts, last 2 parts, last 1 part, okay? But if you have a 4-digit number in here, then it's supposed to print out error, not a valid address. Okay, so let's see if we can write this program. So last 3 parts, last 2 parts, last 1 part. Okay, well, I mean, let's start with that first. So this is like a printf. Last 3 parts, and then a space, and then a string. The string is going to be called last 3 part, maybe. And then we'll continue that twice more with last 2 part and last 1 part. Okay, so something like this. So the other thing we need to do is we need to get the user input. So we can do... So we've been using like scanf to take in user input. Actually, scanf should only be... It should only happen once, right? So scanf to type string. And that would be assigned to the IP address variable. So we need to define it up here as well. So IP address, this is a character array. So this is a character array, and how large is it going to be? So it's going to be a maximum size of 4, and then 4, and then 4. 4, 4, 4, 4, so that's like 16. 16, it's a maximum size of 17. Because there has to be like a new character in there as well. So scanf, and we'll assign it to IP address. And just to do a little bit of debugging, we'll just leave this stuff out first. So scanf assigned to IP address. Does this work? So we'll just try printf IP address after this. I suppose we also need to write a little gets. Sorry, puts. So put string input IP address. And then we'll printf IP address. See if it works. Run the program. Okay, warning format string expects argument of type character. So this is line 8. Ah, okay. So we can't assign it like this. Okay, your program is vulnerable to buffer overflow, you know. Probably a good idea to avoid that. I mean, they haven't taught us about buffer overflow yet, but I mean, ideally what you would do is you would use like a different function, right? You wouldn't use scanf, you wouldn't use scanf, you wouldn't use like string copy. You'd use the safer versions to avoid that. But yeah, I mean, by default, these programs are, well, because we're using, you know, the insecure versions of these functions, it's vulnerable to buffer overflow. Okay, you can use scanf, it's fine, you just need to put the length live dangerously. I mean, here's the thing. As hackers, we know about how to exploit code, but learning how to write secure code it's another skill entirely. Like you need to see this from the perspective of the developer instead of the attacker. Scanf 16s IP address. Okay. So does scanf work normally in this case? So input IP address, okay, and then we can do like 255, 255, 255, 255, and then we print it out. Okay, so that seems to go off without a hitch. But yeah, they'll probably teach us later in the course how to avoid code that is vulnerable to buffer overflows. But at this point, it's not reasonable to expect us to know to avoid insecure code because they didn't teach us it. Okay, so input IP address. So this seems to work. So the next thing we need to do is we need to string copy. So we can string copy into a few different variables. So character last 3 part, and we need to give it a size. So this last 3 part is going to be 17 minus 4. It's going to be 13. So last 2 part is going to be 13 minus 4 again, which is 9. And then last 1 part is going to be 4 less than that, which is 5 characters. So we would... So the other thing we need to do is we need to check if we've got digits in there, right? Because they say that we're supposed to print out an error message, error not a valid address. So if a given string doesn't have 3 dots, then the program should print... If a given string doesn't have 3 dots, then the program should print the message, error not a valid address. Okay, so the check should probably go like right after the scanf. So if something, right? So like puts error not a valid address, and then it will return 1, because that's the error That's the error return message. So what is this conditional over here? So how do we check if there are 3 dots in the string? Note you can use the isDigit function, but you can also write your own code to check whether or not a character is a digit. So we're checking for... They didn't teach us about how we're supposed to check for these dots. Check for substring pattern in C code. So check for a substring pattern in C code. You can use the standard library function string, or write a custom manual loop if you cannot use built-in functions. So I guess we could use a custom manual loop to do this. Manual loop without libraries. So if you need to implement the logic from scratch, you can use nested loops to manually slide across the text and check character matches. So we've got a nested loop, which is looking for patterns, right? So they just say check it's only digits or dots, so I think they expect a for loop. Yeah, so we need to do some pointer math, right? So I guess we don't... So the puts error not a valid address, we'll just put that somewhere else. We'll put that in our loop. So for I've forgotten how to write my loops again. So it was like I equals 0, and then was like I less than size of something. I less than size of IP address. And it runs, and each time it I iterates, so I++. So how do we do this across? So we also need to do this as like do this for pointer math, right? Because find substring, loop through the main text. For I equals 0, text I not equal to... Oh, okay. So we're not looking for... That makes sense, because there's going to be a null character at the end of the string. So it's, in this case, it's going to be IP address element I not equal to this, and then I increments. So this would be like IP address I is not equal to the null character. So the null character is \0. Then I iterates. That's what they've got over here, right? Check if the pattern matches starting at text I. So we're doing j equals 0 if text break, mismatch found, stop checking this position. So if the loop finished without breaking, the entire pattern matched. So for j equals 0, so this is looping through the entire string. Sure, this is a pretty standard thing in C language. So we gotta get good at recognizing this pattern. Check if the pattern matches starting at text. So pattern J. So looking for so there are two integers at play here. There's integer I and then there's integer j, and we should probably initialize those in our code as well. And so we got integer I and j. So this is the first for loop, and the second for loop is inside here. For j pattern is not if text I plus j. It's not pattern j. Mismatch found. Okay, let me take a look at what this particular little code block is doing. So j equals 0, pattern j. So in this case, we're looking for pattern at j is not. You don't actually need that sort of complex matching here. So I mean, the only thing we need to check for in these strings is whether or not there are 3 dots. So we do need to loop through each one of these characters. So like maybe like an if so like a dot counter. So integers I and j. So this is stuff for loops. And these will be stuff for strings. So integer I and j, and then we'll also need another counter for number of dots. Integer. You can do it if is digit IP address I, else if IP address I equals something something. Have you tried Project Euler? I think I've heard other people mention Project Euler before. Agato Systems, hello, nice to see you here. I think I've seen your name before. Were you mentioning Project Euler before? A series of challenging mathematical computer programming problems that will require more than mathematics insights to solve. Oh, okay. So are these... The intended audience includes students for whom basic curriculum is not feeding their hunger to learn, adults whose background was not primarily mathematics but had an interest in things mathematical? So these Project Euler problems, are they typically solved using scripting or something else? I mentioned it the first time here, but I wrote here before. Yeah, I think I've seen your name before. Okay, so let's go back to this page. So integer dots, we can initialize it as 0. And we can do like a little check. We'll increase the number, well, the dots integer value each time we encounter a dot, and if it happens that we find 3 of them, then that check passes. Bold of you to think that we can do math, that's true. Anarchist says if you store the parts as a character pointer, parts 3, then you can simplify your logic a fair bit. So let's see. So IP address. And then if we store it as like pointing to parts of the IP address, we'd have to separate it out by the dots, right? So the last two part, the last 2 part, and the last 1 part, these all need to be defined because we want to print them out at the end. So if we put in 255 4 times, then we're supposed to print out a message that looks kind of like this. Okay, might be a good 2 birds, 1 stone challenge. So here we ran across the entire string IP address. And then, okay, you can printf string parts 0 if you define it as I said. So parts 0. Parts 0, which is the first element in the array. And I mean, is there an easy way to assign the parts? You don't need to store 3 separate character arrays and then string copy into them as you seem headed to. Yeah, I mean, that's what I originally was going to do, just use string copy to copy out the other 2 parts into this array. But I mean, I might come back and try it again with some other methods. Zammer says, does it ever make sense to store the octet separately and just construct the strings on the fly? Does it ever make sense to store the octet separately and just construct the strings on the fly? I mean, they want the user input to be just one string. So 1 string of an IP address, and then they want us to separate it out using our program and print out the different parts of the IP address. But, okay. So the way I'm thinking about doing this might not be the most logical way to do it, but it's just a way I'm thinking of solving the problem. So we keep track of the number of dots in here, then we run through the string. It's probably not very efficient. Okay, also your current method is going to overflow buffer on any invalid input. Really not a great approach. Okay, overflow buffers. I mean, we could try doing what you suggested earlier. Sure, can't we scan F into the array? Scan F into the array with something like string dot string dot string dot string octets 0, octets 1, and octets 2, and octets 3. Let me think about that. So we scan F string dot string dot string dot string dot string. Octets 0, 1, 2, and 3. I mean, the thing is that we're not... The user input isn't guaranteed to... The user input isn't guaranteed to have 3 dots. That's part of the problem. But yeah, I mean, Anarchist mentioned that we might want to modify the scanf function so that it takes in only like a certain amount of strings, right? So for example, like 16 length string here. So like %16 string into IP address. So maximum of 16 characters, right? So run over the string, and then so for j equals 0, and then the pattern is not 0. J increments. The inner loop, that was just for more complicated processing. Zemmer says, like I said, I don't really know C. It seems like Anarchist does. Yeah, it really does seem like Anarchist does. Anarchist, can you tell us what your experience is with C? Because it seems like you know your stuff. Okay, so j equals 0. So 4, well, I mean, we can just use this outer loop. So the outer loop is this, and we'll get rid of this code block. It's like if IP address I is equal to a dot character, then do something, right? What do we call that thing? Dots? Dots plus plus. So increment the dots variable. Okay, let's see. Anarchist says, C knowledge is fine, that's a decent approach. Just not what they're suggesting. Not a skilled C programmer, never really written anything in it, but I know the basics from reversing and other stuff. Oh, okay. What would you say your most your strongest programming language is? So would it be something like Python or JavaScript or something else? Just trying to get a feeling for where your training and education is. So dots increment, and then I guess at the end of the loop, if dots does not equal 3, well, okay, let's make sure that this looks nice and organized. So at the end of this for loop, if dots, well, okay, we gotta put this inside of parentheses. Oops, like this. If dots doesn't equal 3, then print out that message, right? So the message is not a valid address, return 1. Okay, Anarchist says, I've done quite a lot of Python, C#, and Java, in roughly that historical order. Plus starting to learn Rust, and okay at read-only for C and C++. Oh wow, you've learned a lot of programming languages. Is this part of like is this part of development work, or for some other purpose, or is like a hobby kind of thing? I get the feeling that it's probably part of some job roles that you've done in the past, maybe some developer roles. Okay, so not a valid address, return 1. If dots does not equal 3, and then I guess the other thing we could do is we could scan isDigit. What is the isDigit? IsDigit function C. Okay. As in Java, then C#, then Python. Professional work in most of those. Java is more of a hobby. I mean, Java and C# are very, very similar. Correct? I mean, I heard that Microsoft basically ripped off Java and turned it into C#. Zammer says, anyone who can interact with C or C++ more than reading scares me. I mean, people checks whether a given character is a decimal digit character 0 through 9. To use isDigit, you must use the C type H header file. Int isDigit int C. Wizard stuff? Is it wizard stuff? Okay, the character to test passed in as an int. The behavior is technically undefined if the value is not represented as an unsigned character equal to EOF. Returns a non-zero value true if the character is a digit and a 0 false if it is not. Yeah, just start doing it and keep doing it. I mean, anybody can get much better at writing in a programming language if they just practice writing programs in that programming language, right? Pass is an integer, its ASCII value. The behavior is technically undefined if the value is not okay. Okay, let's see. Java / C# started similar, both VM-based ripoffs. VM-based ripoffs of C and C++. They diverged a fair bit due to early decisions. C#. Okay. Generics and Java erasing them. Haven't followed Java recently, but I think it's caught up a bit. Zamru says, I work now mostly in JavaScript and Ruby. I did some Python in the past, but never professionally. Okay, so I mean, we have the ability to count the number of dots in the string and then output an error message if we don't have exactly 3 dots at the end of the string. But figuring out if the IP address has nothing but digits, this is a bit harder because we expect that there's going to be like, oh, we can also do like a if-else kind of thing, right? So also, if IP address is a dot, then dots increment. If dots is greater than 3, then put the error message. But we can also do it like another check here. So if IP address I is not equal to If IP address I is not equal to a dot and, well, no, it's going to be this and, right? So and then we need to do another one, IP address I is digit, not, what was the is digit function? So we did do is digit over here. Is digit IP address I, then print out the same error message. Anarchist says, sorry, the rayifying stuff was for anyone more technically minded. Sorry for the word salad. I don't recognize that word. I'm not too sure what the word rayifying is. I kind of thought that it might be like a misspelling of some other word. Anyways, so we'll print out the error message and return 1 if we find any disallowed input. So not a valid address, return 1. It means making something real. Making something real, rayifying. Nullsec says to regard or treat an abstraction as if it had concrete or material existence. I mean, I'm also interested in learning about Java and C# in the future. So maybe after I finish up my course with C, I might pivot into Java and C. Well, Java or C#. I suppose Java is more useful to learn because more software environments historically have used Java than C#, but C# is also pretty popular for modern apps, especially when you're dealing with stuff that works in a Windows environment or like .NET, right? Okay, so this is our first check. So this is the check. To check that checks if it's valid IP address. Although I guess we can debug this now. We'll just do like a printf. Oh, we also need to include like a header. Because if we're using the isDigit function, we need this one. And I guess we're also going to include the string stuff. String.h. Anarchist says Java is pretty dead now, apart from some use in enterprise stuff. Really? I thought Java was used in Android, in writing Android apps. But then again, like there's another programming language that replaced Android development. I think it's called is it called Kotlin? Yeah, Kotlin, right. Java and Kotlin. Buru Noah, hello, nice to see you here. I mean, how similar is Kotlin to Java, though? Or is it, like, totally different? So printf the string for IP address. Okay, Zamru says, if I recall correctly, it still runs Java in the Java VM, but it's more functionally oriented. So Kotlin is more of a like a wrapper or something that runs Java. I'm not sure. Okay, so we'll reset this, and we'll see if we get any errors if we try running this stuff. So this is line 25. So if IP address is not a dot and is not a digit, Oh, I think we need to put an extra one of these. Okay, try it again. Still having a problem. Okay, so 25. Expected. So here's 1, 2, 3. Oh, there's three parentheses. Okay, Anarchist says, exactly to avoid backwards compatibility issues with Java compiled. Java compiler initially erased the type of generic so that they only existed in compilation and not in the actual program bytecode. This limited what they could do. As I said, I haven't looked into Java in years, but it could be dated. So Xamarin says Kotlin compiles to the same bytecode that Java does, and you can use Java libraries in Kotlin, I think. Bruno says, I don't know, I don't use Kotlin. I mean, I don't use Kotlin either. I think it would be fun to learn Java, because there's a lot of like reverse engineering challenges that are also written, that are also binaries that were, that are also Java binaries. Okay, run the code, Gronk. Input IP address. So we'll do 255, 255, 255, 255. Not a valid IP address. Okay, so something happened. Our logic isn't logicking over here. We can also do like a debugging message. Puts the 3 dots triggered. Okay, there are about 700 programming languages, okay? Anarchist says, yeah, both Java and Kotlin target JVM and run on Android version of the JVM, the Dalvik VM. Google says we can. Google says we can do what? Use Java libraries in Kotlin. And then the other one is puts the not number error triggered. Okay, we'll try this again. Oh, need to end every one of your statements with a semicolon, everybody. Otherwise they don't work. Is digit expecting a character or a string? I think isDigit works on both. So it checks whether a given character is a decimal digit character 0 through 9. So it looks like it's looking for a string, or a string representation of these ASCII characters 0 through 9. Okay, so input IP address 255. Darn it. 255.255.255.255. So 3 dots triggered, not a valid address. What's wrong with my logic here then? So if IP address I equals dot, then dots increments. So there are 3 dots here. So the check over here, if dots is not equal to 3, then we give the error message, not a valid address. So I guess the other thing we could do is we could print out the dots value here before this thing is triggered. 3 dots triggered, and then printf. So this would be like decimal. Dots equals Is that check still in the for loop? I think it is. So this one iterates through all of the characters in IP address. Although I guess, All right, let's rerun this. Oh yeah, right. You're right. Line 20, yeah. So we need the double equal sign here. Okay. You're right. This is a pretty basic mistake. So if IP address I equals dot, okay? So dots increments. So if IP address I is not equal to dot and this always happens. Yeah. I mean, I should be able to spot this kind of thing. Okay, IP address 255.255.255.255. 3 dots triggered. The 3 dots triggered, dots equals error, not a valid address. Dots equals 0. Dots equals 0. Okay, so integer dots equals 0. So this part of the program is not incrementing the thing properly. So if IP address I equals dot, then dot should increment. I mean, I guess what we can do here is we can also print out what we're checking over here. So printf the character, and that would be IP address I. That is all triggering on the first character. Your 3 dots check is in the wrong place. Okay, so Zemru says that's all triggering on the first character, the 2. The 3 dots check is in the wrong place. We're not continuing the loop after seeing something valid, we're checking all the conditions. We're not continuing the loop after seeing something valid, we're still checking all the conditions. Okay, let's so this next debugging part over here, we're just pointing out each character in the IP address one by one. So we'll run the program again. So you said I need to check about if we see a number or a dot, we're good. We continue in the first 2 ifs. Okay. Okay. I see what's happening here. So we only check the first digit, and then the 3 dots check triggers. Yeah. Okay. So the 3 dots check should be outside the loop, right? So we put that over here. Okay, so this should be okay then. Or, I mean, I hope so. Okay, so we're printing off the characters one by one. And then we put a new line. This is another thing that I keep on forgetting. I keep on forgetting to put in the new lines. But puts in a new line every time. Okay, run the thing. Enter IP address 255.255.255.255. 255, and it should So print IP address. Yeah, okay, so it successfully went through. So let's put in a couple of like deliberately not valid ones. So 255, 255, 255, 255, and then another dot. And then we'll 3 dots triggered, not a valid address. So that works. Xamaru says, I go back to work this week after 12 weeks of paternity leave. This is making me feel better that I haven't forgotten everything. Yeah, what kind of role do you do, Xamaru? If you don't mind sharing, are you a developer, or are you working in cybersecurity, or something else? Okay, so we'll do one where we do 255, 255, 255, 25A, and then it should also trigger the error. Not a number error triggered, not a valid address. Okay, so it works. But yeah, Xamaru, congrats on getting paternity leave, because it means that you had a great thing happen in your life. Congratulations. Okay, so I guess in this case we don't need the J value, so we might as well not define it. Spawned? Okay. Software engineer in ads. At the moment, happy to say more afterwards. Okay, great. Alright, so the next thing we need to do is we need to... But I was going to like string copy into last 3 part and last 2 part and last 1 part. But we need to find a way to separate this. So how do we do the string slicing here? So we need to find some way to tell the program that everything after the first dot is last 3 part. And then after everything after the next dot is last 2 part, and then everything after the last dot is the last 1 part. Okay, let's think about this. So if we've got like 255, 255, 255, 255. Xamaru says, it's been a whirlwind, but I'm over the moon. Yeah. I mean, I hope you're getting enough sleep, because I hear that new parents often are kept up all night because they need to take care of the kid that is not cooperating with sleeping and all that other good stuff. Okay, so split by so we want to chop off everything before the first dot. So in Python we would do like a split function, but we can't necessarily use a split function here. So we'll run through the entire string again. So for I equals 0, and then I... How did they do it again? Oh, we check to see if it's not a null character, right. So if IP address I is not equal to the null character, which is /0, and then I increments. Then we've got our instructions. Okay. Anarchist says, why run through it again? You're already going through and detecting dots. Now why not do it there? Yeah, I think we should be doing it there. We should be doing it there, but I just need to figure out what the instructions are going to be. So it's basically the same for loop. As I said, string an array of part pointers would simplify things. So storing an array. So it's something like, we would define up here, like, Xamarin says, I think our best bet is to construct octets. Octets is we're running through the string. Alternative, instead of just counting dots, we could track their positions. You'd track the positions of... I mean, Xamarin suggested something like, when we do scanf, we're recording like separate strings. So string dot string dot string dot string, and then recording them to different arrays. So that would be something like, first string is part 1, part 2, part 3, part 4. Something like this. The thing is that it breaks if there are not exactly 3 dots. Okay, Erica says an array means that you don't need if dot equals 0, last parts equals something something, etc. Okay, so I mean, I'd like to learn what you're talking about, Anarchist, but I'm having a hard time imagining it right now. So you're talking about storing an array. We've got one. Currently, we have one array. So let's just pretend our array is IP address, and that's like, I don't know, 17, size 17, and it's equal to this string. So what you're saying would be something like, we've got like a pointer, like a character pointer. So character, like, so like last 3. Character pointer called last 3, and it would be equal to something. Not completely sure. Okay, so you're finding the position of dots, right? So you need to, when you detect a dot at the IP address i+1, it's the start of the next part. It's the start of the next part. Okay, so let's take a look at the code we've got right here. So if IP address I equals dot, then we add 1 to the dots counter, and then we define another thing? Is that what you're trying to say? So dots increments, and then we do something like character pointer last 3 parts. IP address I+1 is a valid character pointer to the remaining string. So let's see. Character pointer last three parts equals IP address I. So something like this. Because I haven't tried anything like this before. So the first time, okay. So if you have character pointer parts 3, then you can just do parts plus dots, parts plus dots equals IP address I plus 1. I mean, I'm having a hard time imagining it. Okay, let me go through it slowly. So IP address I plus 1 is a valid character pointer to the remaining string. So if you have character pointer parts 3, then you can just do parts array plus dots equals IP address I plus 1. Okay, I'd be able to imagine it better if I had some code in front of me, like the full code. Xamaru seems to get it. I still don't get it. Okay, so when you find a dot, put in printf remaining string IP address I plus 1. Okay, I'll try that so that I can better understand what we're talking about here. Okay, so when you find a dot, put in printf remaining string IP address I plus 1. Okay. So dots increments, and then remaining string IP address I plus 1. Okay, well, we'll run the code. Printf remaining IP address. I mean, IP address it's defined, right? Printf remaining string expects argument of type character pointer. Printf remaining what's up with this error here? You might need and IP address. Oh, okay. So this is like dereference. Okay, so we can put in the IP address 255.255.255.255. Okay, so it's kind of, yeah, I can see. So after the dot, it says remaining 255.255.255. Okay, so this is beginning to make sense here. So IP address I plus 1 is a single character. Oh, okay. So we need to dereference it to print out the thing, right? So remaining, and then remaining, well, we need to just ignore this because I guess to fix this we could just, do remaining string and then new line, right? So we'll clean it up a bit by doing it this way. Can also done IP address plus I plus 1 plus I plus 1. Okay, so IP address 255. Okay. So we put in this IP address, and then After the dot, the remaining is 255, 255, 255. Okay, good. And then after the next dot, remaining is 255, 255. And then after the next dot, then remaining is just 255. Okay, so this makes sense. So we just need to assign these to different ones. Are we assigning these to different? Are we assigning these to different pointers? So this would be like last 3 part. The first time it's last 3 part, then it's last 2 part, and then it's last 1 part. Character pointer parts 3, then you can just index into that with the dots, checking that you don't go over 3. Okay, so character pointer parts 3. So parts, okay. Then we can make the parts the thing that we're printing at the end. Okay, so we'll do... So character pointer parts 3. So this is a pointer called parts, which is a character pointer, and then has 3. It has 3 elements. We can get rid of this stuff here. And then these are the things we're printing at the end. So we print F, last 3 parts, and then it would be like parts element 0, and then parts element 1, and then parts element 2. 1 and then 2. Okay, an array of 3 character pointers. 3 character pointers. So it's an array of strings. So parts 0, 1, 2. I guess we need to do a little bit of debugging. There's a bit of debugging left. So here, when we find the dot, then we have to do the assignment, right? So it would be parts pointer to parts equals dereference IP address I+1 when we find the dot. Is this how we want to do it? So at the very end of the program, we'll print off something like well, we can actually print off last 3 parts now, right? So, oh, we still need printf. No, we assign to parts dots. Parts dots. Parts equals I+1. We assign to parts dots. I mean, I don't quite understand that. Hold on. Let me try running the program as is and see what happens. Okay. This is line 22. Parts. Oh no. Parts. Dereference of extra parentheses at the end. Oh, I see it. Yeah. Okay. Okay. IP address 255.255.255. Uh-oh. Something weird happened. Something weird happened here. So last 3 parts is just 255, and then last 2 parts becomes like a big jumble of stuff. This is not going to end well. Nope, I guess it didn't. I guess it did not. Actually, let's... Yeah, so there's just a bunch of garbled stuff here at the end. Okay, Xamarin says, when it sees the first dot, we know what the first thing we want to print is. If parts is what we want to print, that should go into parts 0, no? And so on whenever we see a dot. So parts 0, I mean, we also need to increment. Okay, so this is where we are here. So after we find the dots, after we find the dot, and then remember what type of what the type of parts is. So parts is a character array. So parts is a character array. Do we want it to be something else? It's a character array. That's a maximum. Oh, okay. So I think the size of the character array should be 17 then. Okay, it's a character. It's a pointer. Yeah. So parts is a pointer. Parts is a pointer. So the pointer should have a maximum of... Size is the number of parts, not the length of each part. Size is the number of parts, not the length of each part. The type of parts is more clear with the parentheses, in my opinion. So character parts 3. So if we do character pointer, character pointer parts. So it's an array of characters. It's a character pointer called parts with a total of... Well, I mean, shouldn't this be 2? Since we start counting from 0? No, wait, we don't start counting from 0. This is the size. The size is 3. Yeah, okay. For some reason I thought we were dealing with counting elements for some reason. Okay, I don't know if this really solves our problem here though. The size is 3, the indexes are 0, 1, and 2. So I mean, I'm assuming that when we print out part, well, the element 0, the element 1, and element 2, because this is what gets recorded. Okay, Arnica says if you wanted them to be a fixed size character array, so we'd have parts 317, an array of 3 items, each of which is an array of 17 characters. But we're not storing the actual character arrays, just the pointers to the character, which are null terminated. Okay. So here we've got pointer parts. Maybe pointer parts dots? Because dots is an integer. So dots starts at 0. And I think this would need to go, but without the dereference. So where's my D? So my dereference is here. Check order of store and increment. Yeah. Okay. So we should probably put this here. I think parts is wrong. I'm going to override where parts points. Just want parts dots. So we just want parts dots. Parts dots. We don't need to. Yeah, I need to practice more. I need to practice more C. Okay, so error parts undeclared. First use in this function. Character parts. So this is line 13. Parts undeclared. Parts 3. Okay, so I guess we do need to do it in this format. Okay. Line 21. Assignment makes pointer from integer without a what? Without a cast. Parts dots, IP address I+1. Okay, let's go down. That's line 21. You still need, okay, so we still need the dereference for the IP address. Okay. Enter IP address 255.255.255.255. Okay, so we print out the IP address, last 3 parts 255.555, 255, and last 1 part 255. Okay, so it seems to be working now. I really need to take this thing apart later, and I need to fully understand what the heck is going on. Because I mean, I appreciate all the help that Anarchist and Zamru are given, but I don't think I completely understand. Henky Lodwick says, "Hi Cheyenne, I have some questions. Can you guide me for some documents for doing Android pen test?" Android pen test. I mean, I haven't done an Android pen test before, but I'll help if I can. But what is your question about Android pen testing? Okay, so let's get rid of the debugging print. So the debugging print F stuff we need to get rid of, and then we'll just go back to what we have here. So in the get rid of this. I think it's just looking for resources for learning. So I mean, there's probably some sort of guide for Android pen tests, or like mobile pen test, like checklist or something. Mobile app pen test methodology. Hanky Lodwick says, I need to bypass Firestore authentication. Firestore authentication. Full report in hours. Okay. Yeah, so something like OWASP Mobile Security Testing Guide. This is probably what I would look for. All right, I'll just shoot you the link. Hanky Lodwig says I need to bypass Firestore authentication. I have a Google API key on the application. Oh, I mean, if that's the case, then I'd probably look for something in like HackerFrogs. I don't know for sure about how to do exactly what you're looking for, but we could check for it in here. So let's see. Where's the search is so hard to do in HackerFrogs now. Like Firestore? GCP pen testing, data exfiltration and manipulation, and Cloud Firestore. Cloud Firestore. This is what you're looking for, right? Firebase Firestore. I'll send you the link. But I mean, aside from this, I'm not sure if I can help you any more than this, because I really don't know very much about mobile pen testing. Okay, so let's go back. We'll test the program. So we'll put in our sample input 255, 255, 255, 255. Okay, so the last thing we need to do is we need to make sure we've got some line breaks in here, otherwise it looks messy. Okay. So last three parts to, okay, yeah, this seems to be coming out as expected. Then we do the next one. So 127.0.0.1. Oh yeah, I mean, Henke, I believe you're doing, like, you know, legal hacking stuff. It's just that I don't have any experience with mobile pen testing. Okay, so last three parts, last two parts, last one part. Okay, good. And then we need to output that this is not a valid address when we put in the non-valid address. Oh, you know what? I don't think it covers this. Okay. We need to adjust our program because it's not going to catch this error. So because if we put in 255, 2555, yeah, it still comes out as normal. Okay, the turnip, hello, nice to see you here. How is C going? Well, we're learning lots. We're learning a lot. And we're going to have to come back and do a lot of review later. Okay, so where is the error? These substrings should only be created with the use of pointers. The substring should be created with the use of pointers and array indexing. If a given string doesn't have 3 dots, you should print this message. Okay. You should also check if a given string consists of only digits and dots, and if there are no more than 3 digits in each block. You don't have to check if the numbers are smaller than 256. So we need to check if there are... Well, I guess we would keep track of the digits in each block and then reset each time. No worries, no worries. I'm happy to help you if I can, Hanky Lodwig. Okay, so integer dots equals 0, and then we'll also do like integer num digits equals 0, which we reset every time there's a dot. So we need to do like the check for the number of digits inside of the loop. The turnip says there is a lot to take in all at one time, even if you do it in parts. I've been trying to learn Rust, and it has been a lot. I mean, I don't know. I don't know very much about Rust. What is Rust similar to? The people who know about Rust in chat, can you give it to me as an analogy to like C and Python and maybe JavaScript? And the other thing, the turnip, what kind of background are you coming from, the turnip? Do you know Python? Do you know JavaScript? An overly expressive C. Oh, okay. Okay, so we check for digits in here. So inside of our loop, if IP address, okay, we got another hour or so to go of this stream, so let's go ahead and put 60 minutes on the clock. Just a second, everybody. Anarchist says, so targeting a similar level as C, C++, but focused on memory safety. Okay, so if memory address I mean, I guess we don't need to check for digits because we're also checking for digits or dots over here. So each time, so I guess we just need to like tick up a counter. Maybe down here. So we're still inside of the for loop. You can change the to if dot else if is digit else error. Else error, okay. Cypher says, is there a long stream tomorrow? Yeah, there's going to be a long stream tomorrow, starting at 2 p.m. Pacific Standard Time, going until like 8 or 8:30 p.m. Pacific Standard Time. But yeah, there's going to be a longer stream tomorrow. The term says, I started years ago with Python and then since moved on to C# and then Go and then TypeScript. Huh. I mean, if you know Python and Python, C# and Go and TypeScript, shouldn't it be easier to pick up Rust since you've already seen a lot of different programming languages? Or am I mistaken? And like Rust is something completely different? Or does Rust feel like C, and that's why it feels very different? Okay, so we'll increment for each loop. We'll just num digit increments. And we'll put like an if condition. If num digit is equal to or greater than 4. Equal or greater than 4, then we do something. We also need to reset num digit every time we find a dot. So I guess we would increment num digit like earlier. So before this one, if IP address is a dot, we would increment it up here. So num digit increments, and then increment dots, and then num digit equals 0. Okay. Anarchist says, okay, with a more systems language like C, C++, then Rust is going to be a fair bit. The term says Rust is a bit odd because it uses a borrow checker. Borrow checker, I have no idea what that is. Zamru says, I've tried learning Go a few times. It's neat, but I don't think the way it wants me to. Anarchist says it's solving the problems of C, C++. So if you don't understand those problems, then a lot of Rust makes less sense. The Turnip says, so the memory that you have is not managed by memory allocation or by a garbage collector. When it goes out of scope, it frees the memory. So if you've written any of C++, it's basically like RA2 or RAI. Okay, Zammer says we are incrementing num digits at the top here. Yeah, so we'll increment the number of digits. It starts from 0, and then for each loop, it increments by 1. Because the check for the dot over here resets num digit to 0. And then down at the bottom, we'll do a check to see if num digits is equal to or greater than 4. And if so, then we'll output the error message. This one right here. I guess we can get rid of the type of error message because we don't need that stuff anymore. Anarchist says RAI is resource acquisition is initialization. It's a C++ thing. Okay, so you know, you'd think that this program wouldn't be so complicated, but you know, here we are. Okay, so num digit plus plus expression, expected expression before something token if num digit. So this is, we've got some problems. Okay, so this is line 13. Ah, right. We need some semicolons. Every program is complicated in C. Welp. Okay, so num digit undeclared. First use in this function. So int num digits, and that's 19. 19. So for each iteration of the loop, num digit plus plus. Wait. Oh, okay, okay. Num digits plus plus. Okay. Gotta make sure everything is spelled the same. The old forgot one semicolon compiler train wreck. Okay, we'll run the program. Does it run now? Expected expression before greater than token if num digits equal to or greater than 4. Oh, is it the opposite? Is it the opposite? So 31. So is it like this? Oh no, this is less than. Hold on. This is greater than. I always keep on getting less than and greater than mixed up. It's not a very cute look. I can't believe this frog can program. Hey, it's Rama. Hello, nice to see you here. Okay, so this works. We just need to make sure that we've got the right number of digits. So we're stuck right here. So if there are 4 digits in the IP address in one of the octets, that's supposed to throw an error. What's up, Frog? I'm having a good time learning about programming. Well, quote unquote good time. How are you doing? And what are you working on? It's Rama. And you know what? Everybody, let me know what project you're working on while you're watching the stream, because I'm curious to know. Error, not a valid address. Okay, so it works. I want to copy this. I want to analyze this more closely later. Man, I love programming. Okay, nullsec is working on CPTS. That's awesome. Okay, so I'm just going to save this for later and do a little bit more of a review on this. But we're finished. We're finished this, and we can move on to the next exercise. Hopefully the next exercise doesn't take as long. Maybe recheck valid addresses. I think you might have broken some. Wait, which part is going to be broken? Hey, it's Rama says, I'm writing hardware simulations for lab equipment at this point. Oh, what kind of lab equipment and what kind of, what are you using to interface with the hardware? Okay, Grey Wolf Medi says, I'm dealing with the cyanide script. Cyanide script. Does the script kill you? What does the cyanide script do? Okay, let me maybe recheck valid addresses. Yeah, some other people are curious what the cyanide script is too. Okay, Zamru says, I was working on learning FreeCAD, but now I'm heading towards bed. I hope you can get some good rest, Zamru. And thank you for all the help today. Okay, so we might have broken some addresses. So if number of digits is greater than 4, we print out the error message. I'll try doing the sample inputs again. So okay, It's Rama says all machines have a computer attached to them, so they interface with those computers. I'm writing simulators for the entire package, the lab hardware and the computer that they use. The Turnip says, I'm trying to learn about AI programming tools. They are not working out very well for me, but I figure it is 50-50 of me not doing it properly, and also that the AI is just not doing exactly what I want. I mean, I used to be very interested in getting AI agents to do hacking, but these days I'm more interested in just learning how to teach people how to do the hacking. And I'll leave the agentic AI stuff to somebody else. Okay, so we'll run the program, and then we'll put on the expected stuff. 255. Okay, this works, and then we'll move on to this one. Sample is 127.001, so good old home. Okay, and then we've got this last one, not a valid address, after you put in the 4-digit IP address, or the 4-digit octet. 255, 2555. Okay, might have missed an edit. Looks like you got it right. I'm just not a valid address. Yeah, I'm just making sure that I don't want to do too much because we could be here all night. or we could be here over several days trying to cover all the different scenarios. But yeah, the sample input and the sample output seem to be working right now. Okay, so the turnip says, the more I do this, the more I agree with your thoughts. It's just not fun at all, really. Not fun at all. I mean, the other thing is that I don't have enough money to throw problems at AI agents, because I don't have a company backing me to pay for my tokens. Otherwise, I might be more enthusiastic about this. Okay, let's move on. Okay, Turnip says, there is no joy that you get from solving a problem on your own. There's none of the joy you get from solving a problem on your own, but that's just me. I know some people have a really good time with it. Yeah, it's expensive. I mean... Oh, we're getting kind of close to the end of the section here, because we got 85% done. Printing strings. So how do we print a string? It'll certainly be necessary at some point or another. We can use two functions, and you already know both of them. So the first one is puts, which you remember from the beginning of the course. Now we're going to be using it in a more formal way. The C language functions are described by specifying the prototype. I don't know what prototypes are. The prototype consists of a return type, the type of the result, the name of the function, and a list of parameters as well as their types. So the prototype of puts is shown below. So integer puts. So I guess all functions are integers. Integer puts character pointer s. So this means that puts expects only one argument, the pointer to the string, to be printed. Puts, in contrast to printf, automatically appends a new line character to the output. Here are three valid forms of puts invocation: with the name of the character array, with the name of the pointer of the type character, okay, and then with the string literal. So you can do puts with a variable name. So that in this case, the variable name is a character array. And then we can do a pointer with the type character, and then a literal, string literal, in this case, Boromir. Okay, good. The puts prototype specifies that the function returns a result of type integer. The function returns the result of type integer. What does this mean? How do we use the result? How do we ever use it? How do we use the result? How do we ever use it? Okay, Anarchist says, I think it depends on how you use the AI. I kind of enjoy working through some more complicated issues with AI, but just write the code for me isn't enjoyable. They write the boring stuff while I do the fun bits can be okay. I mean, yeah, I guess finding ways for the AI to help you do the boring stuff is the intended use of AI. That is after you understand what it's doing. The C language doesn't force you to use the function results. If the value returned by the function is really needed, we can make use of it, like in the example in the editor. So integer res. Res equals puts McGonagall. Puts McGonagall. So I mean, I'm pretty sure that puts McGonagall res. So that's going to be, res is going to be equal to 0 or 1. 1 equals true and 0 equals false, or maybe it might be reversed. The Turnip says, I'm sure there is a balance somewhere with it. I think so. I think so too. I mean, the other thing about AI development is that we're still in the infancy stage of people using AI to accomplish like work tasks. So It's like year 4 because the first like GPT models came out in like 2022. It was 2022, right? So we're still like super early as far as where AI is going to fit into the workflow. We might have like a better idea in like 6 years, say. So by the time like 2032 comes around, it'll be much more standardized as to like what AI is expected to do and how we're supposed to be using it in our workflows. So if we ignore the result, like in the second invocation, the compiler will not recognize this as an error. The value returned by the function will simply be rejected. It's not an error. Here's a brief explanation of the result of puts. It's a non-negative number if everything goes well, and a -1 if puts cannot meet our demands due to any reason. Okay, so Anarchist says, thankfully as a solo dev, I don't have to care about satisfying management or competing in questionable metrics with coworkers who use it. I mean, I hear that they're punishing people who are not using AI enough in certain job roles. So people, you know, have like... But I mean, the thing about that is that the culture might be changing right now because companies are starting to feel a big financial strain on the amount of tokens they're using. And the AI companies are also making the tokens more expensive. Okay, so .nath Eisdenak, have you can read backwards? Can you read backwards? Have you considered reading backwards? Hello, nice to see you here. How are you doing? We're just trying to learn some C coding over here right now. Okay, so the result of puts is a non-negative number if everything goes well. So what happens if we print this out? If we just run this. Yeah, there's not enough boilerplate code here. Actually, let's try putting this in our editor here. Okay, and we'll run this code. I mean, it prints it out twice. So res equals puts McGonagall. So it just prints out these the variables. Well, they're not variables. These are string literals. It's too clean and simple to be valid C. Yeah, this is something I'm figuring out. I mean, one of the many reasons why I'm learning C is so that I can start pulling apart the binaries that are used for the binary exploitation challenges, right? So let me get an example. So if we go over to Scilab, and I grab one of the binary exploitation challenges. So let's see, challenge library. We'll do like buffer overflow 2. So when we do any of these binary exploitation challenges, they give you like a C source code file. Copy that. You guys can take a look at this as well if you want to. So these are all vulnerable C compiled binaries, and the reason why I care so much about learning C is so that I can analyze these source code files and understand exactly what's going on. So in here, I have to understand like these buffer sizes over here to understand the buffer overflow exploits that we need to that we need to conduct on the binaries in order to complete the challenges. So here we're opening up files, and we're also trying to trigger these functions. So for this one, if we're able to execute this win function over here, then the goal for the challenge is going to be revealed to us. So flag.txt. But if the flag.txt file doesn't exist, then it's going to print out this message: please create flag.txt. But yeah, it's all about understanding the programs and the software and what makes the code insecure. Okay, where are we? Let's go ahead and move on to the next thing. So the second function is printf. So we've been using a lot of printf. Take a look at its prototype in the editor. So the mysterious 3 dots indicates an arbitrary, including 0, number of parameters may appear in their place. The result of the printf function has a rather original meaning. It's the number of characters that the printf function has successfully sent to the output. So the prototype, so printf returns an integer. And the 3 dots indicates that a number of parameters may appear in their place. So it could have a lot of different parameters, but it also takes in character pointers. Okay, hopefully you can still remember the specifiers, because now we're going to show you another one, designed specifically to print strings. It's %s, where, as you may guess, the letter S stands for string. You can find the example showing how to use it to print 2 different strings in the editor. So S and S are the best. So protagonist and hero, so in this case it would be McGonagall and Gandalf and like I don't know who else is in there. Frodo, Bilbo. Okay, we've used printf statements like this before. Some useful functions. So let's discuss some essential functions that let you work with strings efficiently and smoothly. Firstly, you need to know where their prototypes are taken from. All of them are contained in the header file named string.h. So you have to include string.h. You have to place the following directive in all of your programs that use these functions. We also need the following 2 definitions. Do we? Okay, so character, string array, character. So basically this is a string. It's a string that is a maximum of 50 characters. We have a character pointer called computer. So for each of these functions, we'll provide the following information: the function's name and the meaning of the name, the function's prototype, a description of the function's behavior, including the meaning of the result and the purpose of its parameters, an example of use. You know, something I just realized is that we still haven't learned about user-created functions yet, which is kind of scary since we're like halfway through the course already. Okay, string length, the length of the string. The string length function is used to count the characters in the string, excluding the empty character at the end. Counting starts from the beginning of the string. The string given in the parameter is not modified in any way. So an invocation like this, so string length of pointer, returns 8 as a result, but this one returns 0. Can you explain why? So the pointer array is 8 characters, well, it contains up to, no, it contains 8 bytes. So the pointer is of a length of 8 bytes, so that's why it returns 8 here. But the string literal empty string is 0 bytes long. But I guess they're counting characters, not bytes, but they're kind of equivalent sometimes. String length returns a character, pointer s. String copy. Make a copy of a string. The string copy function makes a copy of a string pointed to by source and stores it at the location pointed to by destination. The string pointed to by source is not modified in any way. Copying involves all of the characters of the string's source, including the null character at the end. The result of the function is the same pointer as the one specified as destination. An invocation like this, so string copy string to ptr, places a copy of the string computer at the location pointed to by the variable string. Wait. So the destination and the source. Oh, okay. So it's copying into string from pointer, because the source is the second thing and the destination is the first thing. Okay, the invocation copy, string copy, Alice has a cat, and string causes the string array to contain the phrase Alice is a cat, along with the closing null character. Okay, good. Okay, and we've got string n copy, make an n long copy of a string. So I mean, this is the memory secure version of string copy. The turnip says a pointer is a fixed size depending on if the computer is 64-bit or 32-bit, or am I mistaken? I think that is the case. Like the pointer is a fixed length depending on whether the environment is 32-bit or 64-bit. Excuse me, I have to get some water. My voice is going out. Sorry everybody, sometimes after speaking for like 3 hours straight, it can be a bit tough on the throat. So string copy. So string copy versus the regular string copy. Let's talk about this. Okay, that's right. Though technically it's the program, not the computer, as you can run a 32-bit program on a 64-bit system. That makes sense. Okay, so it's string copy versus string copy. So this one is the memory secure function, and this is the memory insecure function. So the question's why? It's because, so string n copy checks the destination buffer. Checks the destination buffer's size, as opposed to the regular string copy, which does not. It doesn't check the so that means that with this function, you're not able to perform a buffer overflow attack, but because this one doesn't check the destination buffer size, it can be used for buffer overflow because you can put a 10-byte string into a 2-byte buffer, which means that anything in excess of 2 bytes is going to get overflowed. Okay, so it makes a copy of a maximum n characters taken from the string pointed to by the source, and then stores them in the location pointed to by destination. The string pointed to by source is not modified in any way. If source contains fewer characters than n, all of them are copied. The finishing null character is only added to the copied string if the character is in n range. The result of the same pointer that was specified by the destination. An invocation looks like this. String and copy string pointer 3 fills the array string. Okay, so this is the source and this is the destination with the letters C, O, and M. So C, O, and M because the pointer is pointing to the word computer. Okay. String copy string Alice is a cat fills the array string with the string Alice. Wait, what? So this is the source, Alice is a cat, and the destination is string. But they're using the wrong... Are they using the wrong function here? Okay, Anarchist says both can be vulnerable to buffer overflow or safe if you only provide valid input to string copy, it's safe. And if you give the wrong n to string n copy, it's unsafe. But yeah, string n copy is the safer version. I mean, I heard that they didn't have this version, so string n copy. This didn't exist before they identified that string copy, the original version, was unsafe. Or at least that's what I heard. I'm not too sure if that's actually the way it went down. So why does it truncate this? So Alice says how many? It says 1, 2, 3, 4, 5. So that's 5 bytes. But why does it only put 5 bytes into string? It doesn't say here that it's only moving 5 bytes. Okay, there was no string n copy. You were expected to check before use. I mean, I guess they would have drilled it into you when they were teaching you the stuff in computer science class. Okay. String cat. String cat, string concatenation, append a string to another string. The string cat function appends a copy of the string pointed to. Something tells me that this is also memory unsafe. I haven't really encountered this one before, but for some reason I think this is probably another one of these memory unsafe functions. The turnip says it's because the memory the pointer points to is only allocated so large. Yeah, I mean that's the that's one like big concept of like buffer overflow when we start learning about that stuff. Appends a copy of the string pointed to by the source to the end of the string pointed to by destination. The null character that originally closes the destination is removed, then a copy of source is appended to the destination along with its closing null character. The string pointed to by source is not modified in any way. The result of the function is a pointer that was specified as the parameter destination. Okay, so let's see. Anarchist says string copy blindly copies until null terminators, so if the source is larger, it just blindly overwrites. Okay, so the sequence of operations here, so we got string copy, pointer gets copied into string, and then string concatenation. Pointer gets copied, well, it gets concatenated to string. So it causes the array string to contain computer computer followed by the null character. So the first string copy puts in this string computer, and then the concatenation puts the same string and appends it to the string array. Okay, so this sequence of actions, string copy Alice into string, and then concatenation has no into string, and then concatenate again ptr into string. Fills the array string with Alice has no computer. That's sad. Okay, let's continue. Oh good, an easy difficulty challenge. Great. Familiarize the student with advanced string manipulation, getting words from the user, printing on screen. So a palindrome is a word or other sequence of characters that is read the same backwards or forwards. Write a program that takes one word and prints its palindrome. You can use the for loop, the string length function, and the string format for scanf and print. You can use a new variable or one declared earlier for holding the reversed value of a word. Declare a string big enough to hold long words. For the record, you can use fgets instead of scanf in the future, especially when you want to have long strings with spaces. Your version of the program must print the same result as the expected output. So if you put in book, the expected output is kube. If your input is dictionary, then it is dictionary backwards. Okay. So we just need to print out the thing backwards, right? So we can do fgets. How do you use the fgets function? So fgets saves to like a variable, right? Let me look this up real quick. C coding fgets. So fgets is a standard secure function used to read in a line of text from an input stream. Okay, so fgets character string int n file stream. N the maximum number of characters to read, including the null terminator. So the function stops after reading n-1 characters. So this is what makes the fgets function memory secure, or it makes it more memory secure, I suppose. The source to read from, use standard in for keyboard input, or a file pointer for files. So I'm pretty sure you don't necessarily need to use this part of the... You don't need to define this necessarily. Okay, so let's see. Fgets. I guess we'll character array word, and we'll define it over here. So word is, I don't know, we'll make this a maximum of 20 characters. Fgets word and n equals 20, I suppose. Before that, we can do a puts. Input your word. Input a word. Okay, so we need to print this stuff out. So just for fun, we'll start debugging here. Printf string word. Oh, make sure that all statements are semicolon terminated. N undeclared, first use in this function. Okay, so maybe we don't need to declare n there. 2 free arguments to function fgets. Fgets word 20. So do we need to specify, like, what was it again? Maximum number of characters to read. So use standard in for keyboard input. So standard in. Sorry everybody, I've never used this function before. Okay, input a word, so I don't know, HackerFrogs. Okay, and then just spits it back out at us. Good. Okay, so we need to use a for loop to output the thing backwards and to save it. So after we take in the user input, so we need another character array called reversed. So reverse, and the length of the array has to be the string length of word. I don't know if this works in C. I mean, it would. I mean, I'm not too sure if it would work in Python. We'll give this a try. If it doesn't work, we're gonna have to find another solution. Okay, so we have gets the word, and then for something something, run some code. And then at the very end, we'll print out reverse. So for I equals 0, and we need to define it up here then. Int I for I equals 0, I, and then we need to go until the end of Duck. Hello, nice to see you here. Hope you're having a good day. We're just well, we're on our last leg of our co-working stream right now. I'm learning C programming skills, having a good time. So I equals 0, and word I is not null string, so not equal to /0, and I increments. That we're working C. You can't give any sort of dynamic size like that. It would work in Python. Okay, so in this case, I guess in this case reverse is also like a 20 character array. I guess we'd want to separate this out so that it looks a little bit cleaner. So run through the entire word array. And then we need to populate the reverse. You only have to repeat it. The only alternative in C is to define what you haven't learned yet. Is define what you haven't learned yet, but that's what the Scilab example used. Yeah, you mean this thing? Hold on. This one. Define. So define numbers, or like buffer sizes. Are you good with pointers now? I wouldn't say that I'm good with pointers. I'm slowly learning about pointers. Okay, so you can use a new variable or the one declared earlier for holding the reversed value of the word. So we're reversing out the string here. So it's something like word I. It's something similar to what we were doing in the previous program, right? Because we're appending. Equals like word I. So like reverse. Is dereferenced word I. So in this case, it would be like a pointer called reverse, and it has a maximum of 20 parts. Am I? Something tells me that this is not the way we're supposed to be doing it. So maybe we need to do this as like a nested loop. For I equals 0, word I is not equal to null terminator, and then I increments. And then iterate through reverse as part of like another loop. So for in this case, because we got like a nested loop, we need I and j. It's like for j equals 0. And what would be the end condition of this? And then j increments. For I okay, maybe we don't need the nested loop. So like reverse j equals the dereferenced word I, and then j increments after each loop. Oh man, I don't know if this is the way we want to do it. Anyways, we'll give it a try. The worst that can happen is that the program doesn't work, and then we have to go back to the drawing board. Was this line 19? Format expects some sort of character pointer. Ah, okay. That's right, you just need to know what J should be, what J should be. So is this like the pointer? Reverse J? Integer, assignment makes integer from pointer without something something. Okay. So we got a character pointer called reverse. I'm in the value of initialized J yet. Wait, did we not initialize J? Oh, J equals 0. We can't increment J unless J has a value, and so we initialize it as 0. ISO-C forbids nested functions. We've got nested functions in here. I and declared. First use in this function, this is line 14. Ooh, semicolons. Very important. Okay, you missed a semicolon. The C compiler is just kind of dumb. Well, I mean, it has to... I mean, if we're working in a language with the semicolon terminated statements, we need to follow the rules. Okay, so string argument of the character pointer. This is line 20. Point to it. Input a word. Our word is HackerFrogs. Okay, so we successfully put in HackerFrogs, but it's not reversed. So we forgot that part. No worries. Okay, so we need to find a way to reverse the string. So it's going to be like I decrements, and then I equals, what was it? But we can't really look for the null terminator here. I think we've done this kind of thing before, right? So I equals like string length of word. Or can we do this? And then so the terminator, like the termination condition of the for loop would be I equals 0, right? So like I equals 0. I ran out of tokens, so I guess that's the end of AI learning for now. The turnip, hey, are you using your personal plan, like a personal plan, or is it your workplace that's giving these tokens? Is this valid? I don't know. Should not be 0. So I initializes as string length of word, and then I terminates when I is 0. You can do that. You can also have multiple variables in it, like I equals string length of word, j equals 0, j equals 0, I iterates, I increments, j increments. You can put that in this portion of the for loop too. Let me give this a try. Okay, input a word, book. Okay, something weird comes out. All right. So I equals string length of word. So in this case, like book, string length of word would be 4. I terminate, so the loop terminates when I equals 0. So after each loop, the thing would decrement. Or maybe it's string length of word plus 1. But I mean, we see here that just absolute garbage is being copied into reverse. Okay, I equals 0 isn't a check, it's an assign. Oh, that's right. Okay, so I is equal to 0. Wait. So the termination is I is equal to 0, right? Okay, input of word, book. Segmentation fault. We crashed the program, everybody. Okay, so you're setting I to 0, then subtracting 1, so you're using memory outside the array, hence garbage. Use I is not equal to 0. Okay, so I is not equal to 0, I decrements. Okay, nothing printed out. So I thought... So word... String that... Okay, so what are we actually copying into reverse J? So reverse J should be getting the dereferenced value of word I. I guess we could debug this by printing it out. So printf a character, and that's word I. And print I and J in the loop to check if the loop is working correct. Yeah. Remember, strings in C have to be null terminated. Strings in C have to be null terminated. So do we need to append a null terminator? So like string concat. String cat reverse from what? Word J after the loop will work. Word J equals after the loop. I mean, okay, that's probably the easier way to do it. Word J. Okay, no, not word J, reverse J. Reverse J equals... Well, we also have to increment J, right? Now there's 2 of all us. Grey Wolf Medi. Wait, how many? Grey Wolf and Grey Wolf Medi. Oh, I didn't know. Wait, are you separate users? Are you separate users, Grey Wolf and Grey Wolf Medi? I thought I was dealing with the same person. Okay, so reverse J equals reverse J. Hold on. So this is the for loop. J increments. And then after the loop is finished, I guess we increment J again. and then we assign it. So j plus plus reverse j equals 0, print the thing. Both with 2.9. Okay, let's see if we can get this done in like 10 minutes. Otherwise, I'm gonna have to call it because I need to get to bed eventually. Okay, Anarchist says when you create a variable in C, it doesn't clear the memory or anything. So if you define the character reverse j, when you define character reverse j there, it just contains garbage. When you create a variable in C, it doesn't clear the memory or anything. So you've already incremented j in the loop, it doesn't need an extra one. The gray wolves are multiplying. So I guess we don't need the j increments here. Oh, does it work if we run the program? Expected before reverse. So this is 17. Okay. Input a word, book. Okay, so we got close. We got close. We got KOO. So we're missing one thing. So I equals string length of word, maybe +1. Maybe put this between some parentheses. Okay, run it again. Ooh. What happened here? Okay, so the final character isn't being appended. So if we do HackerFrogs, yeah. So add j++ in the null string, and the null string. So the null string here, yeah, maybe we do need to add the j++. We'll see what happens when we try that. Book. Still doesn't work. So why is this first character not getting added to the array? So I guess this one isn't necessary. So string length of word +1. I guess the printf statement isn't quite working out either, huh? Printf character word C. Word I. Maybe this has to be a string? What's the first index you want to write? Given string length of book is 4. So the first index we want to do is 3. So it goes 3, then 2, then 1, then 0. Oh. I guess the I has to be, we have to do the check for -1 instead. Because we do want I to hit 0, but we don't want it to hit -0. My I is not less than 0? Okay. So I is not less than 0. Equal or greater than 0, someone hit -2 before -1, it would infinitely loop, plus you aren't starting at 3. Plus we're not starting at 3. So string length of word plus, I thought the +1 would have solved that. Okay. Guess we don't need to print out these characters over here. So the error is coming from line 19, line 16. What's this? Now it's complaining about expected before the not. Okay. String length word +1 equals 5. You aren't starting at 3. Yeah, so I guess we don't need this anymore. So string length of word will put out 4. 4 is what we want if it's the word is book. So I guess we're checking I is equal to or greater than 0 is the check, and then I decrements. What's it complaining about here? Or maybe we're just checking that I greater than 0. So this is not an assignment. It's like this one. Okay, input a word, book. It doesn't print out backwards. Wait. Okay, you can't have equal, greater than equal. Only greater than equal to 0. I fixed it. I mean, it doesn't look like it got fixed because it doesn't print out anything here. Hold on. So we put in book, and then it doesn't print out anything. And the reason you got an error before is because you put greater than, and then equals. This isn't. Yeah. It doesn't like this. It only accepts this. So I mean, something tells me that this is an infinite loop, because nothing happens after I put in my user input. So J increments, reverse J, word I equals string length of word, so it should be 4 if we put in book. So I equals 4, check for termination, I is greater than 0, then I decrements. Okay, you still got the wrong start index. It's not the string length of word, it's a string length of word -1. String length of word -1. And word 4 is the null terminator. Book. Okay. I mean, I thought it would be... So string length of word is 4. So we start at 4, and then 4 is the null terminator. Okay. So you're printing on an empty string, the data you're writing is word null something something null. Oh. I mean, it still it still isn't working right now. So if the string array starts as a null, then nothing prints out because it counts that as the Hold on. We'll do another print over here. So printf. I guess we can also do puts, right? Puts reverse. Okay, so I starts off as the string length of word -1. So I'd like to printf this. So printf the string word I, or maybe like the character, right? But for some reason the printf never seems to go off. Book. Wait, why does it work now? Why was it not working before, but it works? This is all so screwed up. Okay, this is another. Okay, we finished this. I'm gonna have to go back and study this, but I don't have enough time to do this in length right now on stream because I've got to get to bed. I've got to, you know, do another stream tomorrow. Okay, so we'll do the tests, input a word, book. Wait, what? Why doesn't it work? But when I did this, print f word I, the character, this did print out backwards. Code looked fine before. Maybe. Okay, hold on. So it seems that this is printing out, right? So it's printing out, the thing is printing out in reverse because it's part of the for loop. So I think this might be the problem here, that I'm not using the printf statement correctly here. But I'm gonna have to take a look at this after the stream is over. Let's find somebody to raid. Let me take a look at Twitch. Yeah, something's still off. I'm sure the AI is gonna be able to tell me in like 2 seconds what's exactly wrong. But the point is to learn on our own, if we can. Okay, so your cyber doctor is on. Hold on. Okay, your cyber doctor works at a cybersecurity consultants agency as an accountant, I think. And he lives in Spain? I'm not too sure where he lives, but okay, well, we're gonna raid into his channel. Looks like he's doing some cyber quizzes. Alright. Let's go ahead and correct Spain. Thank you. Okay, let's raid into the channel. And we're gonna be back tomorrow at the regular stream time, which is 2 p.m. PST. So let's see. Raid your cyber doctor. Okay, everybody, thank you very much for coming today. And when you arrive on your Cyber Doctor's stream, please give this message. OS Frog, Hip Hop Hack, OS Frog. Just like this. We're going to be back tomorrow. We're going to be doing our regular stream. We're going to be doing Hacker Holidays demos. We're going to be talking about binary exploitation. We're going to be talking about shell coding. And we're going to be trying to solve some challenges that involve shell coding in the binary exploitation category. And we're also going to be solving some new binary exploitation challenges. And it's all about binary exploitation on Wednesday, which is tomorrow. Hope to see you then, but until next time, say hi to Cyber Doctor. HackerFrogs out in 5, 4, 3, 2, 1. See you next time, everybody.